Good afternoon, ladies and gentlemen. In this short video, I'm going to do the preparation problems for practice A in chapter 13. You're going to find practice A very straightforward. So just 4 really quick problems. We'll go through it. I was able to copy the page. Here it is. And this is on page 476, number 10. First one, the compound eyes of bees and other insects are highly sensitive to light in the ultraviolet portion of the spectrum. That would be the electromagnetic spectrum, particularly lights with frequencies between 7.5 times 10 to the 14th hertz and 1 times 10 to the 15th hertz. To what wavelengths do these frequencies correspond? Okay, so in the last chapter, here, I went ahead and wrote this down, what they gave us, practice A. They gave us the frequency range of 7.5 to 10 to the 14th hertz and 1 times 10 to the 15th hertz. They want to know what the wavelengths are for each of those. So in the last chapter, you learned that the velocity or the speed of a wave is equal to the frequency times the wavelength. But here we're talking about the speed of light. And the speed of light is known as lowercase c, and it's fast. It's 3, I'm going to say 0.00 times 10 to the 8th meters per second. And I made for you a handout that says how many thousands of miles per hour that is. All right, 3.00 times 10 to the 8 meters per second. That's the speed of light. So V of light, the velocity of the speed of light is c. So we're just going to replace c, replace V with c. Okay, so now we're talking about light, which is super fast. So we're going to say the speed of light is equal to the frequency times the wavelength. Well, they gave us the frequency. All we want to know is the wavelength. So the wavelength is divide frequency to both sides. Both sides. We get c over the frequency. So the wavelength is equal to c over the frequency. So the first one would be 3 times 10 to the 8th meters per second. And the frequency is 7.5 times 10 to the 14th. Instead of hertz, I'm going to say per second because my per seconds and my per seconds cancel out and I end up with meters. So that's good. It tells me I did it right. All right, so let's see what that is. Now again, parentheses are your friends. So I'm going to say 3 times 10 to the 8th. Bring that down. Divided by, and I need to put parentheses to make sure it's the whole entire denominator, 7.5 times 10 to the 14. Bring it down and close the parentheses. And there we go. I get a really, really small number. So I have to count this kind of calculator. More expensive calculators will do this for you. So 2, 4, 6, 7. So this is 4 times 10 to the negative 7 meters. That's that one. That's the wavelength. That's really tiny. All right, let's do the other one. The other one is the wavelength is c over f is, again, the speed of light, 3 times 10 to the 8th meters per second. And now we want the other one, 1 times 10 to the 15th per second. All right, see what that is. Again, 3 times 10 to the 8th. Bring that down, divided by, and here we go. What is it? 1 times 10 to the 15th. I don't need the 1 because it's 1 time, so I'm just going to go 10 to the 15. There we go. And I get another really, really small number. It seems to be a little bigger, let's say. Let's see, 2, 4, 6, 7. This one's to the 7, so same order of magnitude. So I get 3 times 10 to the negative 7 meters. All right. So there we go. All we had to do was use the formula you already knew, which is the speed of a waveform is the frequency times the wavelength. But now we know the speed is the speed of light. And the speed of light we use as lowercase c, 3 times 10 to the 8th meters per second. All right, let's take a look at the next one. The brightest light detected from the star Antares has a frequency of 3 times 10 to the 14. What's the wavelength of this light? So that should look very similar. What do they give us? They gave us the frequency and they want to know what the wavelength is. Same thing. So we know, and yeah, I do want you guys to make sure you write the first equation first so that you understand. Then you can write, then the wavelength is C over F. C we know is 3 times 10 to the 8th meters per second, and the frequency is 3 times 10 to the 14 per second. So this is more a review of math that I've done with the students. Notice how these are two factors and the threes cancel out. Threes cancel out. So you can use your calculator, but remember when you divide exponents, 10 to the 8th divided by 10 to the 14th, let me write that down. 10 to the 8th divided by 10 to the 14th. Hopefully you guys remember that you subtract these exponents. If you don't remember, you can write 10 times 10 to 8 times and then divide that by 10, 10, 10, 14 times, and you'll see that's going to be the one down here. All the ones on the top are going to end up being 1. So 8 minus 14 is 10. What is 8 minus 14? I should write that down. 8 minus 14, and I like addition, 8 plus a negative 14. That way I make sure I get a negative, and I end up with negative 6. So 10 to the negative 6 meters. Okay, so that would be the wavelength for this frequency. And again, this was just more of a review for you of math. Yeah, you can do it, punch that all out in your calculator, but maybe you would see that the threes cancel out because they're just factors. 10 to the 8th over 10 to the 14th. I just subtract those exponents and I get 10 to the negative 6. All right, next one. What is the wavelength for an FM radio signal on your radio of 99.5 megahertz? 99.5 megahertz. All right, so here we have 99.5 megahertz. Well, remember, the units have to be hertz, not megahertz. And if you remember, hopefully you guys remember, is 1,000. Well, mega is the next one. Mega is 10 to the 6, a million. Okay, so the frequency here is 99.5 times 10 to the 6 hertz. Okay, that's what this thing is right here. I've got to convert it from megahertz to hertz. So again, let's see, I want to know the wavelength is C over the frequency, because you've already written down that C is equal to frequency times the lambda. So what's C? C is 3 times 10 to the 8th meters per second, and my frequency has to be 99.5 times 10 to the 6th per second. Okay, so I'm like, yeah, it's like 3 divided by 100, and then 10 to the 8th divided by 10 to the 6th will be 10 squared, just to kind of check and see if your answer makes sense. All right, we'll do it the long way here. 3 times 10 to the 8th. Oops, good number. 3 times 10 to the 8th. There we go. Divided by, I'm going to use parentheses, make sure that whole entire thing is in the bottom. 99.5 times 10 to the 6th. There we go. Close parentheses. All right, so that makes sense, huh? Because this was 3 out of 100. It's a 0.003 times 10 squared. Well, that ends up being 3.01. So I'm confident that that's correct. 3.015 meters. And now I'm going to look at significant figures. I have 3 here. This one's really actually 3.00. So that's 3. So I should have at least 3 significant figures. So this ends up being about 3.02 meters. All right. Okay, last one, super fast here. What's the wavelength for a radar signal that has a frequency of 33 gigahertz? So before we had megahertz, and megahertz is 10 to the 6th. What's gigahertz? It's the next one. So instead of 10 to the 6th, it's 10 to the 9th. All right, let's see. That's what a giga, now you know what gigabytes mean. Okay, so again, we have our, I always go back to V is frequency times lambda, but oh yeah, that's right. It's C frequency times lambda. See, I only know one. That's the only one I need to know, and then I can replace it by C. So we want to know what lambda is. Lambda is C over F. C is 3 times 10 to the 8th, although I know it's 3.00, meters per second, and I got 33 gigahertz. So this is really equal to 33 times 10 to the 9th hertz. Okay, so again, kilo is 1,000, 10 to the 3. The next one is mega, is 10 to the 6th, and the next one is giga, 10 to the 9th, a billion. All right, so I have to put 33 times 10 to the 9th per second. So I go, this is 1/11th times 10 to the negative 1. See how I did that? 3 divided by 33 is 1 out of 11th. 1 divided by 11, then here's 10 to the 8th divided by 10 to the 9, it's 10 to the negative 1. All right, let's do it the long way here. Clear. 3 times 10 to the 8th divided by 33 times 10 to the 9th. Here we go. Still really small. That makes sense. So 1/11th. And we had to go to the negative 1. So I got 0.009. I needed 3. I guess we could do 2 significant figures. This one's only 2 significant figures. But I got 909 meters. And so this one I can, actually I want to use scientific notation. So here I'm going to say 9.09 times 10 to the negative 3 meters. And if I only want 2 significant figures, I'm going to say 9.1 times 10 to the negative 3 meters. And that's all it is. That's all we have. The great equation here that you already knew, except we're replacing the velocity with c, which is the speed of light. Otherwise, it's the same as what you guys did before. All right, I'll see you next time.